Welcome back to Discovering Geometry with Mrs. Becky Berry. This is lesson 15 and we're starting chapter 3. Today we will be duplicating segments and angles and constructing perpendicular bisectors. So back in the ancient Egyptian times, they often used a compass to mark off distances. Not a compass where you find the direction, but a compass like the geometry tool. During the golden age of Greece, Greek mathematicians made a game of geometric constructions. And Euclid wrote Elements. So Euclid was a Greek mathematician. Around the time of 300 BC, he wrote this math textbooks of sorts, and he sought to define the basics of geometry and then prove further ideas. He did pull ideas from his predecessors, but once Elements was written, everything previous to him was forgotten. Elements was entirely his own. He's often called the father of geometry. So Euclid wrote down the basic rules for constructions using only a compass and a straight edge. And that's what we'll mostly be doing in this chapter. We will discover how to construct geometric figures with a compass and a straight edge, or just with tracing paper and a straight edge. So what's the difference between sketching and drawing and constructing? Well, sketching, a freehand sketch could resemble the figure, but you're not using any tools like a straight edge or measuring. You're just drawing it. It might not be exact. Drawing would be carefully and accurately drawing while measuring, using tools such as a ruler and a protractor. But when we construct, we don't use any measuring tools. We are accurately drawing a figure while using only a compass and a straight edge. So we are doing that from our laws of geometry without having to measure different things. So let's go through how we might do some of these things. Look at how we're going to copy a segment. So here is segment A, B. Do you think you can understand these three stages of how they copied the segment? So this one was given, AB was given, and here we're going to start with C, and we're just going to draw a long line. We want it longer than AB because we want to copy exactly how long AB is. What do you think is used right here to mark this that we're given? Remember, a compass and a straight edge were used. So maybe if we took our compass and put the point right here and put our pencil here and marked how long it was. And if we leave that compass the same distance and bring it over to our drawn line C, could we not also mark exactly where D is? Now AB and CD are the same length. So on your notes page, you have these pictures. Use a ruler to measure AB and CD. Are they the same length? After you conclude that, could you duplicate this segment using just patty paper instead of using a compass? Remember, patty paper is tracing paper. So I think you have a pretty good idea of how you could copy a segment just using tracing paper. How about copying an angle? Here are the first two stages, but we also have to figure out what that last step will be. So we are given DEF. And you can see that we have a compass and we've just drawn an arc right here. Then we just draw another one. This is G. We're going to copy angle DEF onto G. So we're going to leave our compass setting the same and we're going to mark this angle or this arc onto G. Your point will be at E, and then you will mark your arc across the angle. You will then put your point on G and mark your arc across the angle. So here's our compass, and we're going to mark this one. And then we're going to leave our compass the same, and we're going to mark this arc. Now, once we do that, what is happening here? Well, we're going to put our compass right here, and we're going to mark the intersection of our first arc. So now we need to leave this compass setting the same as we do that on the one where we want to copy it. So same compass setting when we go back and forth. That's how we know that it's the same distance. What do you think the last step would be here? Well, we have this point and this point. If we connect our end point, our vertex of the angle to that point, we would be drawing the rest of the arc. Or I'm sorry, the rest of the angle. We would be drawing the rest of the angle when we make it at that arc intersection. So the final step is just to draw the last side of the angle. Now take your protractor and measure DEF and angle G. Hopefully you find that these two angles measure the same. Now think about how you would copy this angle with patty paper instead of with a compass. We're also going to talk about perpendicular bisectors today. A segment bisector is a line, ray, or a segment in a plane that passes through what of a segment? Look at this picture right here. L and N and M are all segment bisectors. Where do they pass through? They pass right here through O, and if we look at the distance between OB and OA, it's the same. So O is the midpoint. So a segment bisector is going to pass through the midpoint of a segment in a plane. Now, we can also have perpendicular lines through AB. Do we see J, K, and L that are going perpendicularly through AB? All of these lines are perpendicular, but they're not all going through the midpoint. So a segment can have many lines that pass through it perpendicularly, but each segment can only have one bisector that is also perpendicular. This line is called its perpendicular bisector. So perpendicular bisector is going to bisect the segment and be perpendicular to the segment. So these pictures are both perpendicular bisectors. S is the midpoint, so line SR cuts PQ in half, and it runs perpendicular. This red line cuts the blue line in half, and it's exactly perpendicular. Now, how can we find that perpendicular bisector? All right, so this first investigation, I want you to get out your supplies and try on your own. After you try it, you can watch the rest of the video that will show you in case you had any trouble. So draw a segment on patty paper or tracing paper. Go ahead and label it PQ. You may want to draw it with ink so that you can see it better. Fold your tracing paper in half, or so that the endpoints of P and Q coincide. Coincide means you want them to land exactly on top of each other. You want the dots of the endpoints to be on top of each other. You also want your line to be on top of itself. When you find that point or that place exactly, then crease your paper along that fold. Unfold your paper and draw a line in the crease. Do you see the relationship of this line to PQ? Use your ruler and protractor to verify what you see. Lastly, I want you to put 3 points on that perpendicular bisector, that line that you drew in the crease. Label those points A, B, and C. Use a compass to compare the distances of PA and QA, that is, the endpoints to the point A on the perpendicular bisector. When we use a compass, all we're doing is making sure they're the same. Or if you have to move your compass, they would be different. Compare PB and QB, that is, B to both endpoints of the original segment. Lastly, compare PC and QC. What do you notice about the distances from each point on the bisector to the endpoints of the segment? Hopefully you're seeing that they're the same distance. So point A is the same distance to the endpoint P as it is to the endpoint Q. B and C, it doesn't matter where you put these points on the perpendicular bisector, they will be the same distance from the endpoints of your original segment. That's going to be really useful in just a minute. So here is the video if you needed help. You're going to draw a segment PQ. And you're going to fold your tracing paper, your patty paper, in about half, but you're trying to line up the exact points of P and Q. When you do, your segment should also be on top of itself. Crease that paper well so that when you unfold it, you can see where that crease is. Use a straight edge to draw a line right in that crease. You want to double check that this is the perpendicular bisector. So then you're going to put points A, B, and C on your paper on that perpendicular bisector. And you're going to want to measure the distance between A and the endpoints P and Q and make sure that that's the same. So once you get your distance between P and A, it should be the same. So you keep your compass the same and then check to make sure it's the same between A and Q. Do the same between B and the endpoints Q and P. So once you set your compass, it should be the same. So again, any point on the perpendicular bisector will be an equal distance from the endpoints. So our perpendicular bisector conjecture is that if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. You could say that it's the same distance. Equal what? Equidistant. It means the same distance. If a point is equidistant from two endpoints of a line segment in a plane, will it be the segment's perpendicular bisector? So now I just want to see if I draw a point that's exactly equal distance between the line segment endpoints, will it be on the perpendicular bisector? If it is, then I find 2 points such that are equidistant from the endpoint. Would I be able to draw the perpendicular bisector? Let's give this a try. Draw a line segment on just any paper. Use one endpoint of the segment as the center, that is the point of the compass, and then swing an arc with your compass on one side of the segment. Keep the compass at the same setting and use the second endpoint of the segment as your center now, as your point of your compass, and swing a second arc that intersects that first one. So you want to aim in the same direction on the same side of the segment. So now the place where those arcs intersect is equidistant from both endpoints. Now use your compass again to make another such point. It's best if you go to the other side of the segment. You may want to change your compass setting, but you could leave it the same setting if you go to the other side of your segment. Then do the same thing on the second endpoint. Make sure that you get 2 overlapping arcs. Connect the 2 points you made from the overlapping arcs. Is this line the perpendicular bisector of your segment? So if you need help with this one, let's try this video. I'm going to start by drawing a line segment. And I've marked my endpoints. I'm going to use my compass, use an endpoint of one of the segments as the point of my compass, and then I'm just going to bring it out enough to make an arc. I'm making the first one at the top. I left my compass setting the same to do it from the other endpoint. Now, I've changed my compass setting to come below, but you could keep it the same. And then I mark from the other endpoint. I have 2 places where I have intersecting arcs. I'm going to use those intersection points, and now I'm going to draw a line between those intersecting arc points. Because those 2 points are equidistant from the endpoints of my original segment, they should be on the perpendicular bisector. It only takes 2 points to draw a line, so I'm going to check, is this the perpendicular bisector? Yes, it's 90 degrees. And when I measure the distance, it's a little over 3 inches, and the same distance to the other side. So the converse of the perpendicular bisector conjecture is if a point is equidistant from the endpoints of a segment, then it must be on the perpendicular bisector. Of that segment. So this chapter 3 is all about construction. Make sure that when you watch these videos, you have your construction tools ready. Paper and patty paper, a straight edge, a compass, something to write with. Make sure that you try these investigations on your own before watching the videos that I've done. Keep all these investigations and conjectures organized and in a great notebook so that you know where all of that material is. Thanks for watching.